All right, we're going to do some more examples now on our linear equations in X and understanding what a solution is and what it means to be a solution. So we have an example here. Lisa solved this equation. X plus 6 equals 8 plus 7x and claimed that the solution is -3. Is she correct? So again, where we see x's, we're going to plug in -3, and then we're going to see if this equal sign holds true. So I'm going to say -1/3. Sorry if I said that wrong earlier, I don't remember. Plus 6. Does that equal 8 plus 7 times -1/3? All right, so when we have -1/3 plus 6, basically what we're doing is we're taking away 1/3 and we're left with 2/3. We're left with 5 2/3. And if you wanted to, you could do the math off to the side, but for the sake of time, I'm going to do that. And then I'm going to say, well, does that equal? Over here, I'm going to multiply. And I'm going to get 8 plus 7 times 1, or -1 there, is a -7/3. And I know we don't like to work with fractions, and if these would not be non-repeating decimal or repeating decimals, we could change them to decimals, but they are. So let me just take this part right here and let's break this down. -7/3. A lot of different ways you could do this, but I am going to take a -7/3, okay, and I'm going to write it as a negative, and I'm going to focus right here. How many times does 3 go into 7? 2 times. That would be 6, and then there's 1/3 left over. So this actually ends up being 8 plus -2 and 1/3. Sorry, I'm squeezing that in there. And remember, mixed numbers actually have a plus sign between them. So this actually ends up being 8 plus a -2, which is 6. So sorry, this is a -1/3 too. Oh my goodness. If you remember breaking apart mixed numbers, this is -2 plus a -1/3. And again, if you don't remember doing that from last year, you can just do it the old-fashioned way and subtract it. Trust me on this, I actually kind of know what I'm doing on this one, even though it doesn't seem like it right now. So this works out to be 8 plus a -2, which is 6, plus a -1/3. I'm running out of room. So 5 2/3. Does that equal, if I take a third away from 6, guess what I get? 5 2/3. Okay. Again, guys, if you needed to just go off to the side somewhere and do your work with fractions here, that's fine. But what we see here is that they do equal each other. So when we have to explain, we say, yes, -1/3 is a solution because both sides equal 5 2/3. I'll squeeze that in. Okay? All right, sorry for the confusion there. Okay. See, it was the same thing we were doing in the last video, though. We're substituting numbers in, and we're seeing if we get true statements. All right. Now, we're going to change things up a little bit here. And in this one, well, you'll see. Claire was able to verify that x equals 3 was a solution to the teacher's linear equation, but the equation got erased. What might the equation have been? Identify as many equations as you can with the solution of x equals 3. Well, we might not do as many as we can, but I want to give you a hint. We know that x equals 3, so if you're writing an equation, start with your answer. Let's do something to 3. Let's add 2 to it. What does that equal? 3 plus 2 is 5, right? Well, remember, a variable represents an unknown number. So we are saying that x equals 3. So let's go the other way now, and let's replace 3 with x. X plus 2 equals 5. And in this case here, if I gave you that equation, what would the solution be? 3. Now, I'm not going to do as many as I can, but a lot of times you're going to be asked to write an equation, and we tend to make it a little more difficult because we try to figure it out without remembering what our solution is. So again, let's say I want to start with 3. and maybe I decided to multiply it by 2 and add 7 to it. I don't know. 2 times 3 is 6, plus 7 is 13. Now, to change that into an equation with the variable x, make this x. So that we have 2x plus 7 equals 13. Okay? When we're writing equations, remember that x, that variable, it's the unknown. It is representing a number. We just don't know what that number is. All right, last one too. It's going to be a little different. Does the equation always have a solution? Do equations always have solutions? And the answer to that is no. No, they don't. Okay? Can you come up with an equation that doesn't have a solution? Well, basically, we need to put things around this equal sign that can never be equal to each other. If I wrote x equals x, say I left some space there, is that a true statement? Yes, because if x was 3, this would be 3 equals 3. If x was a negative 1/3, this would be a negative 1/3 equals a negative 1/3. Always going to be equal to each other. So what if I decided to add 5 on this side? What would we have to add on this side? And I hope you're thinking add 5. Except I want them not to have a solution. So what happens if I added 4? Is there any number we can put in for x that when you add 5 to it, it equals when you add 4 to it? No. So you can do different things like this. If you want to come up with an equation that doesn't have a solution, and we're going to talk a lot more about that later, about equations and systems that don't have solutions, you just kind of have to make it impossible for them to be equal to each other. Okay? So this is kind of the flip side of checking to see if something's a solution. But remember, this whole lesson is really about, and you can kind of read through the summary here, it really is about understanding what it means to be a solution to an equation.